Junkyard Talk with Mark this week. And guess what? We're going to talk about some of the worst engines of all time everywhere. Yes, I'm going to get right to it. Forget about the muss, the fuss. The first one actually is a Toyota product. We're talking about the 2.2 DCAT from 2005 to 2015. Yes, excessive back pressure. As well, their particulate filters were clogged up pretty much by 30,000 miles, which was half of their expected life. Too much back pressure also meant extra strain on wastegates, turbo seals. It blew oil gaskets. Obviously, it leaked oil, coolant. And the worst thing was a lot of these suffered oil dilution. By 92% of these vehicles actually suffered oil dilution issues. That's absolutely tragic. An engine that was not known for durability, longevity by any means. And Toyota, definitely one of the worst for their brand. And the next one is Nissan's infamous or famous 1.5 to 1.8 liters. Yes, Nissan QG engines, they're a huge issue. With too much temperature, 2100 degrees Fahrenheit they've measured in the engine, of course, due to plugging off of the catalytic converters that created all kinds of other problems. They found silicone content in oil samples, and ultimately 8 thou is what they found of oblong in terms of these cylinders. That's right, everything melted down, was starting to expand, and the cylinders were changing shape by as little as 20 to 25,000 miles. It's not one of their best engines, and it's not real a shocker why Nissan, in fact, is starting to struggle with reliability. It's not really a start. They've always struggled with reliability. One of the next most rotten engines is by Saab. Yes, it's the 2.0 or the 2.3 turbo engines. They've had a whole host of issues, and a lot of it was lubrication related. The turbo engines, of course, excess end play, not enough lubrication. Even the pickup tubes for the oil for the engine was restricted. And as little as 35,000 miles, it was restricted by 81%. In some cases, they found oil analysis revealed about 77% oil blockages, and it ultimately created bearing failures. Lots of rod bearing issues, turbocharger failures, and anybody driving one of these Saabs of the 2.0 or specifically even the 2.3 turbos realized in short order, in very short lives and miles, that these engines would not last. Saab, I wouldn't want to fly in one of their planes. The next engine is an infamous one by Audi as well, and Audi is not exactly known for the highest level of reliability. They've had some great engines and not such great engines. The 2.5 liter V6, that's right, not to be mistaken for the 2.5 i5, which is a great engine. This V6 TDI that they built from 97 to about 2005, clearly lots of issues. Oil restriction problems, as well as heavy metal particulate in the oil were findings that internals of the engine were wearing extremely quickly. Not an engine that was built to last, and certainly not one that had any longevity. 40% of the oil flow for the cooling and the lubrication was restricted in a few short miles, 20, 30,000 miles. So honestly, to get this engine up to 100,000 miles or 60,000 miles was a long stretch, and likely you were going to experience some sort of rod knock, catastrophic engine failures, potential smoke. Just a downright brutal engine for Audi. Another one that we want to talk about is BMW's S65. That's right, their high revving 4-liter V8 that many love. It went in some of their generation or previous, a few generations ago, M3s. And it was a great engine. It was a lot of fun, high revving, but they weren't built to last. We're talking about an E90, E92 M3 specifically, and you found those back in the mid to late 2000s. Great fun, but they certainly weren't built to last. We saw as much as 4 thou bearing tolerances in as little as 20 or 30,000 miles. And unfortunately, even the rod bolts were known to stretch excessively, 3, 4 thou as well. So these engines weren't built to hold together. The throttle actuators as well was a weak point. You had to replace those. They were going to cost you a few $1,000s. You hope you caught those within warranty, or you were going to spend a lot of money. SMG, if you had one of the SMG gearboxes, not the most reliable units either. Ultimately, this is one of BMW's worst catastrophic engines. Lots of fun, but certainly not built to last. Many customers were finding them having to drop the bottom of the engine and replace proactively rod bearings as a preventative maintenance item, and they had to often do that between 40, 50, and 60,000 miles. They failed to do so, they could reveal a catastrophic rod bearing failure. If they took out the rod bearings, they ultimately take out the crank, and it could be a throwaway engine. Catastrophic failures were imminent and they were always abundant. And the next one is an engine that's dialed right into what we've talked about before, and that's how all these engine manufacturers are going smaller and smaller and smaller. 3-cylinder, 4-cylinder engines, turbocharged, high boost pressures are all recipe for disaster. And Volkswagen experienced that with their 1.2-liter TSI engine. Yeah, we're talking about 64% chain tensioner dropped the pressure by about 30,000 miles. They certainly didn't hold up, and you get some chain slap and potentially catastrophic failure because a chain could slip the cog. Lots of issues with valve problems, intake valves, fueling, and of course, with poor timing, out goes your fueling and your running, and everything started to run sloppily. Not a great vehicle, heavy carbon accumulation with these vehicles as well. You know, you also had restricted intake valve flow by as much as 170% because of all that carbon. Knocking, ticking, if you heard strange noises, that was also a common factor. And Volkswagen, this was not one of their better engines and certainly not one of their better years. The EA888 is also a catastrophic one. I just throw that in there. They've had some variations. Some engines hold together a little better than others. A lot of them have timing chain issues. A lot of them have leaks, oil, coolant leaking issues. And this is not an uncommon problem for Volkswagen. They've struggled with a lot of their engines. Another terrible engine. We've talked about this brand over and over again. And unfortunately, Subaru and the 2.0D, specifically from 2008 to 2020, turbocharger issues. Too much end play. Abundance of pressure in the crankcase also took out many seals. Oil leaks. Catastrophic engine failures, carbon formation that would cause all kinds of premature failures, turbocharging failures, as well as cylinder head distortion reaches amount as much as 4 thou. Way too much movement in the engine, way too much flex, the heating, the high pressures, and it just wasn't built to last. Inadequate head bolt torque as well was a key common factor contributing to some of these failures. Subaru has had many issues with some of these 2.0Ds as well as some of their flat 4s. Subaru has not had some of the best reliability records, and this is certainly one of the worst engines that I've ever seen. The next one is a BMW product. That's right, the N14. You ever heard of the little Prince engine? Specifically from the mini cars. Yeah, we're talking about some of those little engines that were fun at first, but customers unfortunately saw a lot of issues with this. BMW PSA collaboration created this engine. It was direct injected and it was fun. It was high revving, but it wasn't that reliable. Timing chain issues. Many timing chains skipped cogs, kicked free because of a 0.8 bar pressure drop in the tensioner system. Obviously allowed the tensioners to slack off and the chains would jump a cog. That would yield to an early premature failure. Obviously you have piston valve hit and you've got a major issue. On top of it, high pressure fuel pump, lobes, saw some external wear or internal wear by as much as 15 thou in peak areas, led to obviously poor fueling, poor oiling issues, cam timing issues, chain problems, and as well just fuel dilution problems throughout. Not only that, you saw intake valve flow restricted by as much as 75% or 74% because of a lot of the carbon fouling issues. Just a whole plethora of troubles. If you wanted to get a Mini that had some of the more reliable engines, you'd probably have to get into something a little newer, at least a 2015 and newer, got you out of the Prince engine and into something that was a little bit more durable. The next engine we've spoken about a lot, it's BMW's infamous N63, built from about 2008 to 2012, their early generation of the twin turbo 4.4 liter V8. They saw temperatures in the valley, the V, go up as high as 1800 degrees Fahrenheit. We've spoken about that. The hot V, where they mount the turbos in the middle for quicker spool up time as well as quicker boost back out to the engine. Unfortunately, that created a whole host of issues. And as many as 85% of the engines out there actually had to sustain valve guide seal replacements. That's right, to start to consume heavy amounts of oil. Timing chains were a problem. Fuel injectors were leaking down. The seals were a problem because everything was getting excessively hot in the top end of the engine. BMW also had to submit essentially a customer care package to look after customers, had to test varying degrees of oil consumption, but ultimately it was an engine with heavy battery draw, heavy oil consumption, timing chain problems, fuel injector issues. It was a catastrophic failure just waiting to happen. There's no wonder there's not many of these left on the road. And although there's been several variations, improvements since then, all of the N63s do represent a challenge. Obviously, a lot of it was thermal controls, and that's what BMW focused heavily on, was better shielding to keep those turbocharger heats away from the engine. Another one, and I hate to say this because earlier generations were great, but this GM, the 5.3 liter Ecotec 3 V8 engine, high revving, fun, performed well when they were new, but there was a lot of problems with them. As much as 1 quart per every 2,000 miles was an oil consumption, as well as we talk about some of the variable valve timing systems, or in this case, the active fuel management was another scenario that this engine saw. The solenoid response is degraded by as much as 62%. That's right, heavy amounts of failures where they were intermittent, putting out patterns of fueling that just wasn't necessarily on par, wasn't timed appropriately. Lots of issues with these engines, as well as a lifter bore ovality of as much as 4 thou by as little as 20-30,000 miles. Clearly lots of internal engine failures. We've heard of lifter issue problems. We've heard of fueling issues. The AFM system is a catastrophic failure just waiting to happen. If they didn't include that, they'd probably be a lot better off. But it was an engine that was so sad and unfortunately took a lot of customers to the bank just collecting another paycheck for another imminent repair. It's a sad state of affairs. Great engine, had huge potential, but it was all the extra add-ons that GM threw in there that caused a whole host of issues. Oh, did I forget to say carbon fouling? And then we have another one. You don't hear a lot of them around. Obviously they don't last very long, or they hadn't. The Renault 2.2 DCI, of course, is a 99 to 2009. Now, by now, most of these are in the scrapyard and they're recycled into some other metal, and they're probably powering a Ford right now. But ultimately, you had this engine thermal degradation. You had diesel problems with high internal crankcase pressures, lots of issues with premature wear on the camshafts, and as much as 65% design specification degradation on internal, crankcase pressure control. It was just a bad engine, high oil consumption, pure carbon fouling issues, and just a lot of challenges all the way around. It wasn't an engine built to last, and they didn't last. The next one is the Mazda Renaissance engine, the 1.3 liter Wankel, 2004 to 2012. Was an engine that just didn't hold up. The RX-8 that it was found in was a great car. It was a great innovative look and design with the suicide doors. It was a wonderful car, but the engine couldn't sustain and hold up. They saw as much as 1 quart per 1,000 miles of oil consumption. 0.006 inches, or about 6 thou, is what they saw distortion, of course, within, and as well thermal imaging showed that there was lots of heating internally in hot spots. Those apex seals weren't made to last very long, and often what they resulted was lots of cranking but not enough fire ignition because they were losing compression. So low compression meant that poor power, poor starting conditions, they just wouldn't start, they wouldn't run, they just burned oil, and they were just a poor design all the way around. The Mazda RX-7 beside it, before it, was slightly better, but this newer Renaissance engine just didn't hold up, and unfortunately that was the beginning of end for the Mazda, the rotary engine. And the next engine, we've talked about Ford. I've mentioned this many times, the EcoBoost engines, the 1.5 and the 2.0. And a lot of people say, hey, the 2.0 is great. It's great in my Maverick. It's great in my Escape. But wait a minute, hang on now. Nah, it's not always true. We've heard of many issues with the 2.0, and the 1.5 is even worse. With the 3-cylinder, of course, we've heard of a lot of issues with the belt that they drive, the oil pump, clearly catastrophic failures. Just a bad set of engines. A lot of statistics show that as much as 5 thou of bore scoring, when you're doing bore score checks or inspections, are finding as much as 5 thou score in the cylinder walls. That created, of course, excessive oil consumption and a premature failure. Head gaskets, absolutely. Blown turbos, excessive end play, absolutely. These were all common problems. And if you were lucky enough to have one that didn't have all these issues, go buy yourself some lottery tickets. But most people who put any kind of significant miles on these 1.5 and 2.0 turbo EcoBoost engines just didn't see them lasting all that long. They had sustained issues, oil consumption problems, coolant. If you ever watch your coolant reservoir, that's another clear indication. And lots of testing and analysis revealed excessive amounts of fuel particulate in the oil, in the coolant, which represented obvious issues. Head gasket problems were prevalent, and certainly an issue with porous materials, bad gaskets, excessive wear, And just the heating elements just meant that a lot of these engines just weren't built to last. It was just a sad state. The Ford EcoBoost, the smaller engines. Another engine that I have to throw on the list we don't talk a lot about is an Isuzu engine. We don't hear a lot of them because they just didn't last. The 3.0 V6 D Max, yeah, diesel engine. They saw excessive wears of everything. Deterioration, of course, on fueling, where they lost the amount of pressure. Cooling passages restricted in 73% of the examined cylinder heads. They saw lots of issues with accelerated valve guide wear by as little as 20,000 miles on it. Cylinder, of course, chain elongation. So the chain would stretch, and ultimately if the chain would stretch, you'd start get bouncing and it could pop off of one of the sprockets, and then of course a catastrophic engine failure is imminent. Under heavy load conditions, they saw fuel pump output plummeted to 50% of its design characteristics. So it just didn't put out the fueling, had timing chain stretch, premature oil consumption, just a bad all-around engine. And Isuzu and that V6, definitely not one you want to buy. Stay away from that. Another one is the Skoda. We're talking about the 1.2 HTP, and you'll find those from 2002 to 2007. Now, you're probably not going to see a lot of these on the road anymore, but just for record, if you happen to look at, the used car market and you're shopping around, you come across this old beater, just be careful. Lots of issues with timing chain, fundamental timing chain reliability. They get sloppy, they get loose. Spring rates, of course, decreased by 28% by 28,000 miles. Critical timing variations were impacted. Cylinder pressure, of course, was an issue as well. And some of them dropped as much as 180 PSI, essentially a hold piston, in other words. So catastrophic engines through and through. Timing chain valve deviation. You also had a lot of aluminum content in some of the coolant, which was indicative to accelerated internal corrosion. So deterioration inside, outside. Again, as always, blown head gaskets, blown pistons, heavy oil consumption, deterioration, and certainly all done at which miles were quite low. This particular Skoda 1.2 was just a trash bag on wheels, and you never wanted to have anything to do with it. Another one is BMW's infamous BMW N47, their little diesel engine. We saw from 2007 to 2012. I've spoken about this as well, turbo diesel engine. Unfortunately, the chains were known to stretch as much as a ½ inch within as little as 30 or 40,000 miles. It's no wonder they were jumping a cog. Lots of issues there, as well as 75 microns of measurement of metal particulate in, of course, some of the oil, which indicated serious issues. Of course, valve guide deterioration. They have all kinds of metal particulate in there. And as well, sprocket analysis showed that the sprockets on the chain guides and the chains were wearing down. The sprocket material was weak, as well as even the chain guides, the plastic guide ramps, those were wearing down, and some of the plastic particulate as well found its way through the engine. So poor oiling, timing chain issues, leaks, you just name it, this was a bad engine and one of BMW's ultimate worst. It's no wonder it got such a bad reputation for reliability. Another one is the infamous Cadillac Northstar 4.6 liter V8 engine. Need I say more? We've all heard about it. Engine issues. By the time you had higher mileage, about 90% of these engines would sustain some significant failure. Twisted heads, lifting heads, of course, blown head gaskets were a common issue. That was typical. Head bolts was an issue. Fundamentally bad design. The threads were a problem. They could pull the studs, and naturally that would lead to premature. Of course, you start to stretch the studs, all of a sudden you have firing through the heads, and now you have a blown head gasket. Not uncommon and typical for a catastrophic failure in this Northstar Cadillac engine. Built by GM, of course. Another engine that I have to throw out there, not a lot of them around either. We're talking about the Alfa Romeo 2.0 TwinSpark 16 valve engine. Yeah, there's been a lot of problems with these vehicles and these engines that are plugged into these vehicles. The dual ignition architecture basically created multiple failure points in these Alfa's engines. The cam lobe wear, of course, reached as much as, we saw as high as 100 or 12 thou. 50,000 kilometers, and you saw about 12 thou wear. It's pretty significant. Timing, valve timing was obviously going to be an issue. If you saw that much wear, obviously your valves wouldn't open enough, right? If you have too much wear on your cams, it's not lifting the valves, it's not opening the valves, you're not getting the fueling or the exhaust out, and it just creates all kind of running issues. Corrosion, penetration in the spark plug tubes created all kinds of partial discharge conditions, misfiring, lots of issues there as well. And as well, we saw higher copper content by as much as 69 parts per million, indicating a premature rod bearing issue. When you see copper and some of those other metals, the soft metals in the oil, when you do the Blackstone testing, quite often that generally means that you've got some significant rod bearing problems. And these engines did. So rod bearings, timing chain issues, oil consumption, you name it. If it wasn't leaking coolant or oil, it was failing. Another one we got to talk about is General Motors, another Chevy 2.2 liter inline four. A lot of issues, basically just a bad design all the way around. By as little as 32,000 miles, we saw some serious catastrophic engine failures. There was as much as a 140 PSI drop in a cylinder. Now, a lot of common gas engines these days are only 175, 195 PSI. So to essentially lose 140 PSI, you've got a hold piston. And that was often the case. Hold pistons, oil consumption, oblong issues. As well, we saw some of the oil passages had restrictions by as much as 20 thou, and the head bolt torque ratings dropped by as much as 82%. Loose head bolts, hold pistons, oil consumption, they were all names of the games. Unfortunately, we can't throw this in there, but we will. The transmissions that were often bolted up to these engines weren't very good either. So if you had a 2.2 Chevy engine, you likely had a catastrophic engine failure, and they just didn't last very long. And with all that said, you're gonna wanna check out that video. That was last week's, where we talk about some of the big recalls, and down there, if you wanna learn of some of the most reliable vehicles, check it out. You're gonna love that video. Hope to see each and every one of you all on the next one. See you real soon. Bye-bye.